Greetings. Today we are going to discuss a topic shallow copy in System Verilog. In System Verilog, we have two different techniques to perform the copy. One is shallow copy and the other one is deep copy. In this video, we'll be discussing only the shallow copy method. Before getting into the details of the topic, let me just give you a brief idea of what shallow copy is like. So let us say that there are two people. One is the person P1 and the other one is a person P2. Now, there is a particular phone in the industry right now, which is going in the market right now, and that phone is, let's say that it is an iPhone. So what happens is, the person 1 gets an iPhone. He gets an iPhone, and the person 2, he wants the exact iPhone. So what he does, he copies the person 1. So now the person 1 has an iPhone, person 2 also has an iPhone. But now there is a problem. So just assume, this is just an example. So there is a problem. What the problem is that the phones are different, but the contents of the phone are same, and they both are sharing the same memory. The person P2 is copying from P1, but the memory remains the same. So each time the person P1 updates a particular feature or an app in his phone, the same feature is updated in his phone as well. So now when the person P2, if he meets another new person, and he gets his contact and he saves it inside in his phone, what happens? This contact number is updated in the phone of P1 as well. So what is happening is both of them are sharing the same properties even though the external features are copied. The same works in the shallow copy as well. Let us assume that we have a class. And now I am creating two handles for the class. The handle is P1 and P2. Now this class has a lot of properties like int, string, etc. And it also has an object. What is an object? Object is nothing but the memory allocated to a class. It has an object. So when I perform shallow copy, all the properties are copied from this class to this class. But the objects are not copied. It is going to be shared between the object class P1 and P2. I hope you get the point now. Now let's get into the definition of the shallow copy. The shallow copy is used to copy just the class properties, that is the first level properties like integers, strings, instance handles, bit data types, byte data types, etc. The objects of the class can never be copied. So that is what is described in this particular points. Now, in order to perform shallow copy, we need to understand the syntax of the shallow copy. So now let's look into that. Now let me say that I have a class called packet. Now I am going to implement this packet during the runtime. In order to implement it, I have to create a handle. So I am going to create two handles. One is packet space packet underscore 1. So this is the first handle. We have done it, right? Now again, what I'm going to do is, using the shallow copy technique, I am going to copy the contents of pkt. I'm going to copy the contents of packet 1 into packet 2. In order to do that, first I have only created an object for packet 1 here, right? I have not created an object for packet 2. So I have to create a handle for it first. So packet space packet 2. I can do it like this, or I can do it separately like this and remove the packet from here. Now packet 2 is equal to new. So I am creating a new object for packet 2. And this new object is going to contain all the properties of packet 1. So packet 2 is equal to new of packet 1. This is the syntax for shallow copy. The constructor which is used to perform the shallow copy is none other than the new constructor. So with this, I hope that you have understood how shallow copy is implemented in System Verilog. Now let's go on to see the example. Let us assume that I have two classes. One is called as subclass and the other one is called as transaction class. Now in this class called subclass, I have an object. I have a property called as int object obj, and this particular property is of type int. Now I have another class which is called as transaction class. In this transaction class, I have a property called as data. Okay. In this data, along with this data, I also have a subclass. Okay. I am inheriting. What I'm doing, I'm creating an object for this subclass inside this transaction class. So here, this is going to be class subclass space sub underscore h. So what is going on here? I am creating a handle for the subclass in order to create the object. So sub underscore h is a handle for this class, and when I say is equal to new, a memory is allocated. So what is present in the subclass? It contains a property called as obj of, which is of int type. Now let us see how the shallow copy is performed. So we know that using the shallow copy, the properties, the contents of the classes are never copied, or classes are never copied, only the properties are copied. Now the first technique that we are going to do is we are going to create a module test. So inside this, I'm going to create two handles for the transaction class. So for the transaction class, I'm creating two handles, trans underscore h1 and trans underscore h2. In order to perform shallow copy, I am creating an object for the trans underscore h1. So for that, I have to use trans underscore h1 is equal to new. Okay, with this the object is created. Now what I'm doing, I am so trans underscore h1, that is a transaction class, it contains a property called as data. So let's just draw it. So trans underscore h1, so trans underscore h1 is a first class. So trans underscore, this is none other than trans underscore h1. Now this particular class has a property called as data, and now I'm telling that the property data which is present inside the trans underscore h1 should be assigned the value 4. Now this value of data is equal to 4. And similarly, I'm telling that inside this transaction class, we also have a subclass, right? And this subclass is going to have the handle sub underscore h. Now in the next statement, I'm telling that the object which is present in sub underscore h of the transaction class 1 should be assigned the value 5. So now I'm assigning the value 5 to the sub underscore h. Now I'm going to display the value of object of subclass, which is nothing but 5, because 5 has been assigned. Now I'm doing shallow copy. What is this shallow copy is, I am going to copy the contents of trans underscore h1 into a new class which is trans underscore h2. Okay, I'm going to create a new class which is trans underscore h2. This is trans underscore h2. Okay, so whenever I create a new object, new memory is allocated. So there is a new memory for data, but the subclass is not copied. What it means is that instead of creating a new subclass, it is going to point to the same subclass. So trans underscore h2 is equal to new of trans underscore h1. When you display the value of trans underscore h2 dot sub underscore h dot object, it is going to again display the value 5, since the objects are not copied. So this is what is the example of shallow copy of system Verilog. We can have another example. Now let us say that we have two classes. Class A, this is class A, and this is class B. Class A is having a property called as integer j, which is of value 15. And class B is having a value integer I, which is of value 10. Now I am creating an object of class A inside class B. So what happens in this particular statement is, class B contains a subclass of A. So class B, it contains another class of A. The name of the handle is A. I'm using a constructor new to create the object. Now in the main module, okay, I'm going to create two handles for the class B. For this particular class, I'm creating two handles, B1, B2. Now, before performing shallow copy, I'm assigning a object to this handle B1. So now the B1 is created as a handle. So now there is a handle called B1. So what is present in the class B? It contains a property called as I is equal to 10, and it also has a subclass A. So now here I is equal to 10, and it also has a subclass of A. Now we are going to perform shallow copy. In order to perform the shallow copy, that is, I'm going to copy the contents of class B1 into B2. I'm creating another class which is B2, and whenever I create I'm creating a shallow copy, so B2 is equal to new of B1. So when I say new, which means object is allocated and the contents of B1 goes to B2. What is present in B1? I is equal to 10. So that is copied. But as I mentioned earlier, the objects of one class is not copied to the other class in shallow copy. So B2 is also going to point to the same subclass object A. Now I'm going to allocate the value I is equal to 20. So now what happens? B2 of I is equal to 20. When I say B2 of I is equal to 20, the object which is present in B2, the property, that is, the value of I is changed to 20 only in B2. The value of B1 is not changed. But when I change the subclass property of B2, it is changed in B1 also. So what this statement says is that the property J, which is present in the subclass A of the transaction B2, is assigned the value of 30. So now when I say this, the property of the subclass is changed, and this is changed for both the handles B1 and B2 because the subclasses are not copied. So now when I display the value b1.i is equal to modulo d, what happens is, what is the value of b1.i? It's equal to 10. Now b2.i of modulo d, what is the value of b2 of i? It is equal to 20. So properties are copied. Now separate memory is allocated for properties. Now what happens when I say b1.a.j? b1.a.j, the value is 30. And what happens when I say b2.a.j? Again the value is 30. So this is the shallow copy. I hope you have understood the concept. Thank you for watching the video.